B5 now. Okay. B5 part 1. So we have y equals 7 minus 16x plus 4x squared plus log x power 8. For what values of x is the above function defined? So the only problem is with the log. We cannot have the log of a negative number or 0. X power 8 is always positive because the power 8, but it could be 0. So we have to exclude 0. So in other words, we can say x is any real number except 0. So we can write it like that, or if you prefer, you can write it like this. Or if you really want to, you can write it like this. All are acceptable. Just choose one, I don't mind. Okay, part 2. We have y equals 7 minus 16x plus 4x squared, and I'll just take the 8 down. Right, we want the derivative of this. So derivative here, dy dx, that is minus 16 plus 8x plus 8 over x. I think I'll write that as 8x power minus 1. Okay, part 3 is calculate the second derivative. So the second derivative here, so in other words, the derivative again, that would be 8 minus 8x minus 2. Part 4 is calculate, find the stationary points for this function. So that is when the first derivative is equal to 0. Since x is not allowed to be 0, we have no problem here multiplying by x. Oh, I could have cancelled the 8 there. Well, I'll do it here. So we have x squared minus 2x plus 1 equals 0. So let's see, our two answers here would be x minus 1 equals 0. So actually we only have one answer here, x equals 1. I put 1 back into my function to get y. So 7 minus 16 plus 4. So y is then minus 5. And then finally, the inflection point is when the second derivative equals 0. So we have 8 minus 8 over x squared equals 0. So we have 1 minus 1 over x squared equals 0. So we have 1 equal to 1 over x squared. So we have x squared equal to 1. So x could be plus or minus 1. So we have x equals minus 1 or 1. So I already know what happens if I put x equals 1. I'll get y equals minus 5. I have to put minus 1 in now. 7, and then it'll be plus 16 plus 4. I get 27. Okay, so there are the two inflection points, and the inflection points being when the second derivative is 0, and there is the one stationary point, the stationary point being when the first derivative is 0.